In our modern world, we expect digital services to work like a light switch. You flip it, and the light comes on. But behind the scenes, the physical world is messy. Servers overheat, cables get cut, and software glitches. Welcome to the Blueprint for Unbreakable Systems. In this course, we move past the hope for the best approach and dive into the art and science of high availability. You will master the 3 pillars: redundancy, monitoring, and failover, to build systems that don't just survive failures, but thrive in spite of them. From calculating 5 nines uptime to implementing global continuity in Microsoft Azure, we are going to show you exactly how to design mission-critical systems that simply never go dark. Don't leave your uptime to chance. Let's build something unbreakable. In our digital world, we expect technology to work as reliably as a light switch, instant and certain. But behind that smooth experience, the physical reality is messy. Servers overheat, hardware fails, and software glitches. High availability is the engineering art of ensuring that when these breaks happen, your service stays up. It stands on 3 essential pillars: redundancy, which provides spare tires for every vital component; monitoring, the constant watch that identifies a failure the moment it happens; and failover, the automatic switch that moves your work to a healthy backup. We measure this success in nines. The more nines, the less downtime. While achieving 5 nines requires massive effort, for mission-critical systems, it is the essential price of survival. Before we start building, we need a plan. Creating a resilient system is all about balance. You can add countless layers of protection, but that drives complexity and cost up. It's an essential trade-off between risk and your budget. How do we find that perfect balance? By measuring 2 key metrics. First, mean time between failures, MTBF. Basically, how long can we expect a component to work before it breaks? Next, mean time to recovery, MTTR. How fast can we get things back to normal after a crash? We use these metrics to identify our single point of failure through a process called failure mode analysis. Let's look at a restaurant. It doesn't matter how many chefs or waiters you have. If you only have one stove and it breaks, the business stops. We map dependencies to ensure no single component can bring your entire operation to a halt. Think of compute as the virtual brains of your application. If you rely on a single virtual machine, you're vulnerable to a hardware crash. To strengthen the engine, we use availability sets to spread your VMs across different physical racks, ensuring one blown fuse doesn't take you offline. For even better protection, we move to availability zones. These are like independent neighborhoods with their own power and cooling. If one neighborhood faces a disaster, the others keep running. Finally, scale sets act as your automated workforce, instantly adding more brains to handle a surge in visitors or swapping out unhealthy machines automatically to keep the system fast and reliable. Data is the lifeblood of your business. While servers can be restarted, lost data is often permanent damage. To protect this memory, cloud storage uses replication, creating multiple copies of your information. You have 3 main levels of protection. Locally redundant storage, or LRS, is the budget-friendly choice that keeps 3 copies in one building to protect against a single hard drive failure. Zone redundant storage, or ZRS, spreads those copies across 3 different data centers, so your data stays safe even if an entire building is lost. For maximum safety, geo-redundant storage, or GRS, sends copies to a completely different region hundreds of miles away to survive massive disasters. Finally, while standard geo backups are like a locked vault, Read Access GRS allows your users to read that backup data at any time, ensuring a smooth experience even during a regional outage. The relational database is the heart of your application, tracking everything from customer orders to inventory. Because this data is constantly changing, it is highly vulnerable to hardware failure or human mistakes. Thankfully, modern cloud databases come with built-in time travel. Features like point-in-time restore allow you to rewind your database to exactly how it looked minutes or even days ago, the ultimate fix for accidental deletions. For mission-critical systems, we use active geo-replication. This keeps a live copy of your data in another part of the world. If your primary site goes dark, an auto-failover instantly switches your application to the secondary database. By combining redundant compute, dispersed data, and self-healing databases, your system won't just survive failure, it will thrive through it. In this course, we explored the high-stakes world of high availability. where the goal was to transform messy physical realities into always-on digital services. We began by defining the three pillars of HA redundancy, monitoring, and failover, which allowed us to measure success in the nines, aiming for that gold standard of 99.99% uptime. We then moved into the planning phase, where we utilized failure mode analysis to eliminate single points of failure while balancing key metrics like MTBF and MTTR. Finally, we implemented these strategies across the Azure ecosystem. We strengthened the compute layer using availability zones and scale sets. We protected storage through geo-redundant replication. We secured the database heart with point-in-time restores and active geo-replication. By the end, we had built a system that didn't just survive failures, but thrived in spite of them.